Okay, so far we've learned that relative dating, like applying the principle of superposition, attempts to put events like rock layers and when they were cemented down in order. But what we're going to be learning today is the difference between relative and absolute dating techniques. And so we're going to do that through a song. We really do have a song in each unit. And so you're used to this, right? You're going to record yourself singing it back to me as evidence that you've learned your song. So I'm going to sing it through once, just singing. Then I'm going to slow it down and like talk you through the motions because this song is faster paced and I want you to learn the motions and connect them. So then we'll sing it with like the motions and the lyrics just normal time. So this song, is actually called Across the World, but it's to the tune of the Buckeye Battle Cry. So we will have background music. Again, this first one is just going to be me singing. Okay, here we go. Across the world, people wonder what happened in the past. Rocks and fossils whisper clues, geologists find the news. Sometimes the clues show order, sometimes they tell the age. And if the clues do not appear, scientists go in a rage. Relative shows order, superposition, younger above older, they can go out of order. Disruptions, you can have intrusions of igneous rocks. False folds and tilts can disrupt the rocks and make a mess. Absolute is exact, no guessing about the age. You can know for certain, find the radiometric date, use half-lives, just count the numbers of unstable isotopes that have broken down and are no longer found to know the age. Okay, so here comes the next step. Our next step is for you, hang on. Too much of the Buckeyes there. Okay, so our next step is for you guys and girls to learn the song lyrics and to also learn the motions that connect to them and why. So we start out with a true statement that people wonder about the past. It's natural, it's human nature to wonder. So we go like this, I'll do it, and then maybe you just say it with me from home. Okay, so across the world, people wonder, like you're scratching your head, right? Now point back. What happened in the past? Okay, start from the beginning. Ready with me? Across the world, people wonder what happened in the past. Okay, so listen and then do it with me. Rocks and fossils whisper clues, like you have a magnifier. Okay, do it with me. Ready? Rocks and fossils whisper clues. Okay, now this one, like you're opening a newspaper. Okay, say the line with me. Geologists find the news. Geologists find the news. Okay, now next one, still your magnifier. Sometimes the clues show order. You go. Sometimes the clues show order. Sometimes they tell the age. So you're going to point at me because I'm older. Okay, sometimes they tell the age. And if the clues do not appear, ready, do it with me. And if the clues do not appear, now stomp your feet like a toddler. Scientists go in a rage. Scientists go in a rage. Okay, whole stanza all together, across the world position, go. Across the world, people wonder what happened in the past. Rocks and fossils whisper clues, geologists find the news. Sometimes the clues show order, sometimes they tell the age. And if the clues do not appear, scientists go in a rage. Now, in this song, you have to take a deep breath in between stanzas. It's like this, da-na-na-na-na-na, and then it just starts. So you gotta go, okay? And then here comes the next stanza. And this stanza is all about relative dating. So listen, then repeat. Relative shows order. With me now. Relative shows order. Now this is a review term. We're going to make Superman. Superposition. Superposition. Now this is tricky. I'm going to point to you. You point to yourself. Younger above older. Then you point to me, right? Younger above older. They can go out of order. You go. They can go out of order. Disruptions. Disruptions. Okay, now this part, I wanted to show you guys some stuff. Okay, check this out. So these are examples of disruptions. So if you study this with me, this is a place in Colorado called Black Canyon of the Gunnison. And you can see this is the Gunnison River down here. But what is very interesting is something that's happening here on the painted wall. I bet you're noticing these veins of lighter color rock going through. These are called intrusions. Now notice in the song it says you can have intrusions of igneous rock. So what's actually happening here is that magma has snuck in like an intruder and cooled down, okay? So in the song, you can just say this after me. Here's what we'll do. Get ready to sneak. You can have intrusions, like you're on your tiptoes. Ready? You can have intrusions of igneous rock. Okay, now, then the song gets really fast. It goes like this. Faults, folds, tilts. Now let me show you. In real life, this is a fault line. I picked this picture because notice the people, right? It gives you a sense of scale. But this break in the rocks is called a fault line, a crack or a break. And you notice that the rocks have obviously slid on this fault line, which would really cause earthquakes. We'll get into that more with plate tectonics. But notice here should be matched here. This layer should be right next to this layer. That's what we mean by it being disruptions. Intrusions of igneous rock literally melt and erase what was there. Fault lines don't erase what was there, but they can offset it and make it difficult to use the principle of superposition. So in our song, we break the rock and call it a fault. Now notice, even though it's broken, there's still contact between the two sides, though, in real life. Okay, now this, study that with me. I hope you see multiple U layers. Now, nature does not lay rock layers down like that. Nature lays rock layers down perfectly flat and horizontal, like in the bottom of our sedimentary cup. So this is called a fold or a bend. So in the song, we go like this and fold. And actually in nature, sometimes the folds look more like a capital A than a capital U. They can have both. And then finally, I love that picture. Study that with me. These are great examples of tilts of sedimentary rock layers. And notice how slanted they are. That's what a tilt is. So in the song we go faults, folds, and then tilts. And so something has happened. There have been forces within the earth that have done the tilting after they've been laid down. We know nature would lay down these rocks horizontal at the bottoms of lakes and oceans, so there had to be a disruption later. So now let's go back to that second stanza and do it all together. Okay, so get in your relative shows order position and say it with me. Relative shows order, superposition, younger above older. They can go out of order, disruptions. Now this is the fun part. You can have intrusions of igneous rock. And this part is fast. Faults, folds, and tilts can disrupt the rocks and make a mess. Okay, now it's a deep breath because it's like da-na-na-na-na-na, and it's the next stanza. So where relative dating just attempts to figure out the past by putting events in order, absolute dating is different. So we go like this, like we're pointing on a paper to the exact right answer. Absolute is exact. You go. Absolute is exact. No guessing about the age. No guessing about the age. Now look smart and proud. You can know for certain. You go. You can know for certain. Find the radiometric date, like you're tuning an old radio. Find the radiometric date. Use half-lives, so cut it in half. Use half-lives. Just count the numbers of unstable isotopes. You go. Just count the numbers of unstable isotopes that have broken down. Ready? That have broken down. Now look confused. And are no longer found to know the age. And you point to me. So I understand that there are fancy words in here. Half-lives, isotope, radiometric date. This is meant to be an introduction for you. Later on, a few lessons from now, you're going to be learning exactly how radiometric dating works. But for today, know there's actually ways to find the absolute exact age. Okay, so all together in this stanza. Absolute is exact. No guessing about the age. You can know for certain. Find the radiometric date. Use half-lives. Just count the numbers of unstable isotopes that have broken down and are no longer found to know the age. Okay, now, this is it. I'm going to turn the music back on. You're going to hit record on a device, and you are going to sing this with me and submit your video.